Okay, greetings, guys. This is just a key or a method to these exam 2 samples. Now, on this, there's not always going to be enough room for me to work out problems on this itself. The real test, there will be lots more room. So I may switch back and forth between other papers. Now, okay. Warning, by no means assume that the actual test must have similar problems. The sample test reflects expected topics only. So this is just giving you expected topics and kind of the difficulty and style you may see, but that's it, okay? So don't look at this and saying, oh, this is exactly what, no, it's not going to. Okay, let's consider this. Consider this equation. Log of base 3 of this junk plus log base 3 of this stuff equals 4. Which student is proposing a valid first step? Remember, to solve logarithms, you're going to isolate the logarithm, and then you're going to rewrite it or cancel the log, and then you'll solve what's left. So first thing I could do is isolate the log. Well, there's 2 logs here. So I could move one over here, but then I've got to combine it with the 4, and I can't do that. But the other way I can combine these logs is to combine them into one log. And adding one log means I'm going to multiply this stuff. So I'm looking for one. Georgie's first step, no. See how he's added that log? This is bad. Okay? You're never going to have addition in a log expanding out. Lado's first step is to do this. This guy just decided to ignore the logs. That's just dumb. You can't just ignore things because you feel like it. That's the only one. So crud, they're both wrong. So both of them are providing valid first step? No, that's not right. Neither one, there we go. Neither one are providing valid step. They're both going to fail that question. Shame on them. Consider this question. Which statement is providing a valid first step? So again, isolate, rewrite, solve what's left, and check your answer. Those are the 4 steps, right? Isolate, rewrite, solve what's left, check your answer. So isolate the exponential, get that by itself, which means I need to get rid of the 3, which means I'm going to divide by 3 on each side, which will give me 5. So I'm looking for 15 divided by 3. This guy just multiplied the 3 and the 2. That's wrong. 5 equals, there it is, Vaja. I like that name, Vaja. Anyway, that's not right. That's not right. That's not right. Okay, cool. Let x cubed be this and g of x be that. Which of the following is a composition? Composition means one is going to the other. So I need to go, what is f of g of x? So g goes into f. So it's going to be x squared cubed plus 2. See how I put that inside of that? But this I can expand. That gives me x to the 6th plus 2, which is right there, choice B. Cool. Okay, which option is the inverse of this? Well, this isn't really a rational expression because, see, there's only x's on top and x's on bottom. So I would think through this one. I would think, if I put a number in here and I simplified, first thing I would do is I would add 3. And then once I'd added 3, I'd get that number. Then I would divide by 5. Okay, so let's go through that backwards and opposite. So if I start with an x, opposite of divided by 5 is multiplying by 5. Opposite of add 3 is subtract 3. So it's 5x minus 3, which is right there. Okay, now if you didn't see it that way and you like to do it kind of the older traditional way, that's just fine. Switch the x and the y, so that would give me x equals 3 plus y over 5. And then solve. First thing I'm going to do is multiply by 5. Do you see the parallels here? And I get 3 plus y equals 5 times x. And then I subtract 3 from each side, and I get y equals 5x minus 3. There it is. Cool. Cool, cool, cool. Okay, next page. Okay, and I think this is getting near the ones where I might want some scratch paper around, but we'll get to this. True or false? If f of x equals 4x plus 1, then f inverse is this. Well, if I think through this, let's do the same thing. First thing I would do if I put an x in there is I would multiply by 4, and then I would add 1. So if I go through that backwards, I start with x, and I do the opposite of add 1, which is minus 1, and then I would divide by 4. Is that, yeah, that's what they got. So that's true. Natural log of 1 over e cubed is 1/3. Well, let's think through this. Natural log 1 over e cubed, that's e to the -3. Because remember, 1 over an exponential just takes the negative power. And this would cancel. That would be -3, not 1/3. If it was going to be 1/3, it would have to be like the natural log of e to the 1/3, which is the same as the cubed root of e. That would equal 1/3, but not this. So this is not true, which means it's false. If a polynomial equation has a real zero at 2 minus 3i, it's going to have one its conjugate, which is 2 plus 3i. Oh, that's true. The remainder of this, Now, there's two ways to actually find that. I can actually do the division, and I would do synthetic division here, where I'd go 3, -1, 4, and I'd have the 0 of this thing, which is at 1, and then I drop the 3. 1 times 3 is 3, -1 plus 3 is 2, 1 times 2 is 2, 4 plus 2 is 6. There's my remainder. So I know this is false right now. But something else I could do is take the 0 here. The 0 here is x equals 1, because that will make that factor 0. And I could substitute it into here. So I could find 3 times 1 squared minus 1 plus 4. 3 times 1 squared, that's 1 squared is 1. 3 times 1 is 3. 3 minus 1 is 2. 2 plus 4 is 6. So I can either substitute the 0 into that, or to find the remainder, or I could do the division and actually find it. Okay, the determinant of this is 4. Okay, determinants. They're not that bad, but you just got to remember. You know what? This is one I want to do somewhere else. So let me pull out some paper here, and I'm going to copy this matrix. 2, 0, 0, 6, -1, 0, 1, 3, 4. Do that, and okay, cool. So there's that, and I want to find the determinant. To find the determinant, first thing I do is I copy the first two columns. 2, 0, 0, 6, -1, 0 for 3 by 3. And then I want to find the product of these 3 downward diagonals. 2 times -1 times 4 is, wait, this doesn't seem right. That's a -4. That's why it doesn't seem right. -4. Did I copy everything else right? 2, 0, 0, check. 6, -1, 0, check. 1, 3, -4, check. 2, 0, 0. Good. It's all good. Okay. 2 times -1 times -4, that's 8. 6, 3 times 0, oh, that's 0. I like zeros. 1 times, oh, it's 0. And I add these, and I get 8. Cool. Okay. Now I find the upwards products. 0 times, oh, that's going to be a 0. 0 times 3 times 2, that's a 0. 4 times 0, oh, -4 times 0, that's 0. I like zeros because they're easy. Equals 0. You always take the sum of the downward products, subtract the sum of the upward products. So 8 minus 0 is 8. So the discriminant of that matrix is 8. What was the question? The discriminant is 4. That is a lie. So that is false. Okay. Let's look at this. This matrix times that matrix equals that. Well, yuck. Okay. I want to do this one on another paper too. So I've got 1s and -1s, right? Okay, 1, 1, 1, 1 times -1, -1, -1, -1. Okay, so this is a 2 by 2 matrix. This is also a 2 by 2 matrix. And remember, to multiply matrices, these two numbers must be the same. They are the same, so I can multiply this matrix. Okay, so what's going to happen is I'm going to multiply this row by this column. To do that, I multiply top element, first element, second element, and so forth. So 1 times -1 is -1. 1 times -1 is -1. Okay? Now I'm going to go first row, second column, which over here will be in the first row, second column. 1 times -1 is -1. 1 times -1 is -1. I think I'm seeing a pattern here. Now I go second row, first column. 1 times -1 is -1. 1 times -1 is -1. And then second row, second column puts it second row, second column. 1 times -1 is -1. 1 times -1 is -1. And in the end, I end up with -2, -2, -2, -2. There. Now we can see it. Okay. So product here is that, it's just a true false. Yeah, that's true. Okay. Yuck. I'm looking at the next one. Okay, the log of this equals, okay. So let me think about this. I can pull these out. I add the top, subtract the bottom. So I'll get the log base 4 of x squared minus the log base 4 of x cubed square root of y. Okay. Since these are both come from the bottom, they're going to make negative logs, and I see a negative log and a negative log. Okay. This 2 can pull out front. So I'm going to have 2 times the log base 4 of x right there minus this 3 will pull out. I get 3 times the log base 4 of z. That's a z, not an x. Minus this, and that's a z cubed. That's not a square. That's a square root, which square root is a half. So half times the log base 4 of y, which is right what I have there. So this is true. So that's true. Okay, cool. Now, others. Consider the function. How many zeros does it have? Oh, well, it's 4th degree, so it's going to have 4 zeros. Okay. Now, I've got to multiply that matrix. Goodness sake. Multiplying another matrix. Okay. Multiplying matrices is not bad. Let me just copy it down here. Okay. Okay, so I'm going to multiply those matrices. And first of all, this is a 2 by 2. This is a 2 by 2. Since these two numbers are the same, it can be multiplied, and my result is going to be a 2 by 2. Okay? Okay. So, now. I'm going to multiply first row by first column. So 2 times 2, that's 4, plus 0 times 1, that's 0. Okay. First row, second column. So 2 times 0 is 0. 0 times -1 is 0. So that's going to be 0 there. Okay. Second row, first column. So 1 times 2 is 2. -1 times 1 is -1. Okay. Second row, second column. 1 times 0 is 0. Excuse me. -1 times -1 is +1. And so my answer is 4 plus 0 is 4. 2 minus 1 is 1. 0 plus 1 is 1. 0 plus 0 is 0. Cool. There it is. So there is my answer. 4011. 4011. Put it in brackets because it is a matrix, and there it is. Okay. The solution of 2 log base 3 of x equals 8 is, well, 2 log base 3 of 8, or x, equals 8. I'm going to divide by 2 on each side, and I get the log base 3 of x equals 8 divided by 2 is 4. Then I'm going to exponentiate. I'll cancel that with that base of 3, and I get x equals 3 to the 4th. Well, 3 to the 4th, that's the same as 81. So there's my solution. Cool. Okay. Okay. Sorry. I can't be yawning like that. That's terrible. The remainder of this division. Okay, so I'm going to actually do this division. And since that's a linear divisor, I can divide by it, -2. Oh, except it's not -2, it's +2. It's the 0 of that. So I have 3, -1, 5, right? 2, 1, nothing. Cool. 3 drops down. 2 times 3 is 6. -1 plus 6 is 5. 2 times 5 is 10. Is that right? +2, 3, -1, 5. 3 drops down. 2 times 3 is 6. -1 plus 6 is 5. 2 times 5 is 10. Yeah, that's right, 15. So my remainder is 15. Okay. This one, I'm going to do part of it here. Okay, so I look at this problem, and I've got 4 times this matrix. Well, if I multiply 4 times this, I get 4 times all 4 of these numbers. So it gives -4, 0, 8, -12. Right? I think so. 4 times -4, 4 times 0 is 0, 4 times 2 is 8, 4 times -3 is, yeah, that works. Okay? Minus 2 times all of this. Well, 2 times all of this, 2 times 1 is 2. 2 times 1 is 2. 2 times 3 is 6. 2 times 2 is 4. And if I subtract these, I just have to do element minus element. So a -4 minus 2, that makes a -6. 0 minus 2, that makes a -2. 8 minus 6, that makes 2. And then 8 minus 4 makes 4. So there I get -6, -2, 2, 4. So -6, -2, 2, and 4 is the answers that I have. There we go. Cool. Okay. Now this one, I think I'm going to have to step away from the test entirely because these look like ones I'm going to take more room to do. So it says let f of x equals 1 over x plus 3. I'm just writing it down over here. 1 over x plus 3. And g of x equals 1 over x plus 2. 1 over x plus 2. Okay, so first thing it wants me to find is what's f of g of x. And then it wants me to find the domain of f of g of x and put it in integral notation. So I need to find this and then find its domain. So this is part A. Okay, so to find this thing, I'm going to take this and put it into that. So 1 over x plus 3, except instead of x, it's going to be 1 over x plus 2. Okay, now there are a lot of ways to look at this. Let me show you a couple. I think a lot of y'all are doing it this way, where you're thinking, I'm going to multiply this top and bottom right here by x plus 2 over x plus 2. Is that the way you're doing it? I think you are. And I get 1 over x plus 2 plus 3 times x plus 2. That's 3x plus 6 over x plus 2, which is 1 over 1 plus 3x plus 6. Well, 1 plus 6 is 7 plus the 3x all over x plus 2. And then if I do 1 over a fraction, I know it just flips that fraction. So I've got x plus 2 over 7 plus 3x. Okay. Now, first of all here, I see that, x cannot be equal to a -7 because that can't be over the 3. So if I take 7 plus 3x cannot equal 0 and I solve it, that's what I get. Okay, now let me show you another way of simplifying this for a second. And I actually really like this. So if I rewrite this 1 over x plus 2 plus the 3, if I multiply, I look at everything, this term, and that term, find a common denominator. It's going to be x plus 2. So I multiply this by x plus 2, this by x plus 2, And this way, x plus 2. So I've really multiplied the whole denominator and distributed. Check out what happens. This cancels. And I get on the top, I get x plus 2 from right here, 1 times x plus 2. And I get 1 plus 3 times x plus 2. Well, 3x is 3x. And positive 3 times positive 2 gives me 6, which that gives me that. Okay? Now, if I'm not really careful, I'll think that, hey, this is now my domain. X cannot equal negative 7/3. But remember, when you find the domain of compositions, find them up here before you simplify. Because you see, you might see something here. There's another denominator. I can't have a negative 2 there because negative 2 plus 2 is 0. So that gives me another restriction. And then this whole denominator, when I simplify it, gives me the 7 plus 3x. That's where I get x can't equal negative 7/3. So here's my domain. I just put it in set below. Oh, except it said do it as an interval. So I got negative infinity to negative 7 divided by 3. That's like 2 1/3-ish. So negative 7/3 union negative 7/3 to negative 2 union negative 2 all the way to infinity. So I went from negative infinity to infinity, and I skipped over negative 7/3 here and negative 2 there. There's my domain. Okay? Cool. Now, let's look at something else. So the last problem on that page gives this function. Find f of x equals x minus 1. Or it says f of x equals x minus 1 over 2x plus 1. And I have to find the inverse and then find the range of the function. Okay, well, find the inverse. To find the inverse, I need more room than I have there. So I'm going to look here. Okay. This isn't one that I can do the think through approach that I talked about earlier. This is one I've just got to switch through. So I'm going to change this to x's, and I'll change this to y minus 1, and this to 2y plus 1. And I'll multiply both sides by the 2y plus 1. Remember, when you are finding inverses with rationals, you are always going to multiply by the denominator. It's always going to be the way it works. And that's almost always going to have two variables like this. 2y times x, that's 2xy. And 1 times x, that's plus x. Equals, that cancels, and I get y minus 1. Now, I want to get rid of the y on the left, or right, and move it over here to the right. So y minus y is gone. And then I've got this, but I want to get rid of this x, because it doesn't have a y over on the left. X minus x is gone. And so I've got 2xy minus y equals negative 1 minus x. Right there and right there. Okay? Now, remember, the next thing you're going to do is you're going to factor out the y. Always, because that's the only way to get it out of two terms. And I get 2x minus 1 equals negative 1 minus x. Now I just divide both sides by this 2x minus 1. And I get that y is equal to negative 1 minus x over 2x minus 1. So, there you go. I get that. So, that's my inverse. My inverse is negative 1 minus x over 2x minus 1. Negative 1 minus x all over 2x minus 1. Okay, and then it said to find the range of the inverse. Well, the range of the inverse, the range of this thing, the range of this is going to be the same as the domain of this. The domain of this just has that 0. Oh, it is. It's 2x plus 1. Okay. The range of this, the denominator can't be 0. So 2x plus 1 cannot equal 0. So if I solve that, I get x cannot equal a negative 1/2. And so once we're talking about range, we're talking about the y value, the output value, the range, the y value can't equal a negative 1/2. Okay? And now to put that in an interval notation, I just go negative infinity all the way to negative 1/2, and then union negative 1/2 all the way to infinity. And there is my, whatever I said, range. That's right. Okay, cool. I'm a little tired of those problems. Last page. Okay. I'm going to have to use another paper on this. This is 7 papers. Okay, so the last page, I've got this polynomial. It says f of x equals 2x cubed plus 3x squared plus 8x plus 12. And it says list all the possible rationals, find all the real zeros, and then find all the complex. Okay, so first thing, I got to list all my rationals. The rational zeros are going to be positive and negative. Factors of this 12. Well, factors of 12 are 1 and 12, 2 and 6, 3 and 4, and I think that's it. All over factors of 2, which are 1 and 2. So positive and negative. All of these over 1 are going to be positive and negative 1 over 1, positive and negative 2 over 1, positive and negative 3 over 1, positive or negative 4 over 1, positive or negative 6 over 1, positive and negative 12 over 1. Okay, now what if I put these all over 2? 1 over 2, oh, positive or negative 1 over 2. 2 over 2, I've already got that. That's 1. 3 over 2, I don't have that. Positive, negative 3 over 2. Okay. 4 over 2, I've got that. That's 2. 6 over 2, I've got that. It's the 3. And 12 over 2, I've got that. That's the 6. So there's all my that's a lot of possibilities. That's like what? 1, 2, 3, 4, 5, 6, 7, 8 times 2. I'm sorry, guys. I'm yawning. That's terrible. That's like 16 possibilities. Okay. Wow. So that's part A. Part B is find which one or ones of these are real. Wow. So I need to test them. I can test them either by substituting these values in here and see if they give me 0, or I can do synthetic division. Now I noticed something. This has a leading coefficient of 2. That tells me one of its factors is going to be something like 2x plus or minus something. Okay. Well, that tells me at least one of the factors are going to have a fraction in it. And I've got 4 to choose from. 1/2, positive and negative 3/2. So I'm going to start with the 3/2. And I am partial to synthetic division. So I set it up 2, 3, 8, 12. Okay. Drop the first thing, 2. 3/2 times 2. Well, 2 times 3 is 6. Divided by 2 is 3. 3 plus 3 is 0. 3/2 times 0 is... Wait, 3 plus 3 isn't 0. 3 plus 3 is 6. It'd be nice if there was a 0, but the only way to get a 0 there is have a negative 3, which would mean that's a negative 3/2. I'll have to test that next. 3/2 times 6. 3 times 6 is 18. Divided by 2 is 9. 9 plus 18 is 17. 3/2 times 17. I don't know what it is, but it's not negative 12. So that didn't work. What about negative 3/2? I think that will do what I was talking about earlier. 2, 3, 8, 12. Make a negative. 2 drops down. It's going to be a negative 3. Because negative 3/2 times 2 is negative 3. 3 minus 3 is 0. Negative 3/2 times 0 is 0. 8 plus 0 is 8. Negative 3/2 times 8 is 3 times 2 is 24. 24 divided by 2 is negative 12. Hey, look at that. That's cool. That's done. So 208. That represents, this was an x cubed, so this is an x squared, so that represents 2x squared plus no x's plus 8. Hey, check this out. I can factor a 2 out of there, and I get x squared plus 4, and I can solve this. If I take x squared plus 4, and I set it equal to 0, that means x squared plus x squared equals negative 4. And if I take the square root, the square root of negative 4 is a positive and negative 2i. 2 because the square root of 4 is 2. I because the square root of the negative is an I. Cool. Okay, so this isn't bad. So for part B, they just said find the rational zeros. And I found one. X equals negative 3/2. And then for part C, said find the complex. So I found them. X equals positive or negative 2i. And there's all my work for it. Okay, so that's it, guys. That's that problem. Okay, let's do something else. Whoa! Use matrices to solve it. Check this out. Use matrices to solve this. So I got to solve this. So I'm going to copy that thing down. I see 1x plus 1y plus 1z is 6. I see 2y. Oh, 2y. So that's a 0. 2y, 5z, negative 4. And then I see 2x, 5y, negative 1z. And that makes 27. Okay, so let me look at this and this. I'm just going to double check it. 1, 0, 2, check. 1, 2, 5, check. 1, 5, negative 1, check. 6, negative 4, 27. Okay, that works. Okay, row operations. Okay, row operations all about making zeros. The ones, yeah, I'll make those, but the zeros are more important. So I'm looking at that, and I've already got a 0 there, so I want to get a 0 here or here. There's going to be easier. So I need to add a negative 2 to that, which means I want to need to turn that into a negative 2. So 1 times negative 2 is negative 2, and then I'm going to add that to line 3. So negative 2 times 1 is negative 2. Negative 2 plus 2 is 0. Negative 2 times 1 is negative 2. Negative 2 plus 5 is 3. Negative 2 times 1 is negative 2. Negative 2 minus 1 is negative 3. Negative 2 times 6 is negative 12. Negative 12 plus 27 is 15. Okay. I'm sorry, I'm getting drowsy. I'm not sure that's right. I'm going to check again. Negative 2 times this. Negative 2 is 0. Negative 2, 3. Negative 2, negative 3. Negative 2 is negative 12. Okay, that's right. Okay. And then I've got 0, 2, 5, negative 4, 6, 1, 1, 1. Okay. Cool. So now I've got that. I need to eliminate these, and I'm going to use each of them to do it with. So I'm going to multiply this by a negative 3. Actually, you know what? See this 0, 3, 3, negative 15? I'm actually going to just go 1/3 times line 3. And we will get a new line 3. So if I go 1/3 times all of this, I get 0, 1, negative 1, 15. That's going to be easier to work with. One, 1, 1, 6. Okay. Now, where can I get a 0? Oh, if I multiply this by 5 and add it here, that'll get rid of this. So, okay, let's do that. 5 times the third line plus the second line. So 5 times 0 plus 0 is 0. 5 times 1 is 5 plus 2 is 7. 5 times negative 1 is negative 5 plus 5 is 0. 5 times 15, that's 60, 75? Yeah, 75 minus 4 is 71. Is that right? Is that right? Is that right? Is that right? I seemed like I missed something. 5 times 15 minus 4 gives me 71. Yeah, that's it. I don't like that because I get an ugly fraction, which isn't necessarily wrong, but I just don't see those variances. So I'm going to double check things for a second. Did I write it down right? I'm just looking at 1, 2, 2, 1. Is this number 10? Oh, no, because this isn't a 2x. There's a 0 there. So 1, 0, 2, 1, 0, 2, 1, 2, 5, 1, 2, 5, 1, 5, negative 1, 1, 5, negative 1, and then 6, negative 4, 27. So that worked. Okay. And then I did negative 2 plus that. So negative 2 times 1 is negative 2 plus 2 is 0. Negative 2 is negative 3. Negative 2 is negative 2 times 1 is negative 2 plus negative is negative 3. Okay. Negative 2 times 6 is negative 12 plus 27. Negative 12 is going to be 15, right? Yeah. Okay. And then I had this 0, 1, 1, 1, 1, 6, 2, 5, negative 4, 0, 3, negative 3, 15. Multiplied all these by 1/3. Which gave me 0, 1, negative 1, 15. There's the problem. 1/3 times 15 ain't 15. 1/3 times 15 is 5. That's why I hope that gave me. So this isn't 71. See how nice it is if you've kept track of what you've done every step so I can backtrack. So if something seems wrong. So I'm going to go 5 times 5. That's 25. And then 25 plus the negative 4 is 21. There we go. Because now see what I have there? If you don't see it, it's not bad. I've got here this equation. That equation is 7y equals 21. If I divide by 7, I get y equals 3. Okay. Now, if I put that back into here, I've got 1y, so that's 3, minus 1z, that's minus z equals 5. And if I subtract 3 from each side, I get negative z equals 2. So z is equal to positive negative 2. Okay. Yeah. Last, I'm going to put that stuff back into one of these equations. I'll put it in the first one. So 1x, so that's x plus y, 1y, 1z, plus 3 plus the z, which is a negative 2, equals 6. I just put it back in here. 1x plus 1y plus 1z equals 6. And I don't know x, so that's it. Okay, equals 6. 3 plus negative 2 is 1. So x is equal to 5. There's my answer. If I want to put it as an ordered triplet, 5, 3, negative 2. And that is it. Whew. Okay. Let's look at something else. What's the next problem? The next problem says 2 natural log of x equals natural log of 14 minus 5x. And it says solve it. Okay, so I'm going to solve that. 2 natural log of x equals natural log of 14 minus 5x. Okay, so I'm looking at that, and if I move this 2 up in there, I can do that because a coefficient becomes a power. I get natural log of x squared equals natural log of 14 minus 5x. Well, since I have a log equals a log, I can just take the insides and set them equal to each other. So x squared equals that, 14 minus 5x. Cool. Now, that's a quadratic. So I'm going to set it equal to 0. X squared plus 5x minus 14 equals 0. And I'll solve this. This is factorable, I think. X and x, positive and negative, because it's a negative 14. Factors of 14 and subtract make 5. Oh, it's a positive 7, negative 2. So x is equal to a negative 7 and a positive 2. Cool. But now I have to consider any extraneous. And if I put a negative 7 into there or there, that's going to make a negative number. So that's extraneous. 2 works. And so x is equal to 2. That's it. Okay. Cool. Almost done. Check that out. That is nice. Okay, so the next problem. There's a grundle of things here. It says let f of x equal 2 to the power of x minus 2 minus 1. F of x equals 2 to the power of x minus 2 minus 1. Okay. And it says state the domain in interval notation. List the x-intercepts, list the y-intercepts, write all the asymptotes, graph the function. Okay, I'm going to actually do this a little out of order, but I'm going to do a few things. First of all, I'm going to start with graphing it for a second. If I graph this sucker, and I start with y equals 2 to the power of x. Let's make a t-chart here for a second. X, y, 0, 1, 2. If I put a 0 in here, 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. So I've got 0, 1 right there. 1, 2 there, and then 2, 4 right there. And I remember this is going to look like that. Okay? Exponentials look like that. Now, transformation-wise, what is happening at this stuff? What's happening on this? Well, this minus 1 is going to shift it down 1. This minus 2 is going to shift it right 2. And realize this has an asymptote right there. So if I was to regraph this, if I take that asymptote and I shift it right 2, doesn't change, but down 1 does. So this is going to have a new asymptote right there. Then I just need to take every one of these points and go down 1, right 2. So down 1, right 2, puts it right there. Down 1, right 1, 2. So it was here. Down 1, right 1, 2, right there. And this was at 2, 4. So 2, 4 right there. And it goes down 1 and right 1, 2. And there is my graph. Okay, now that helps me because actually I can see my new x-intercept. My new x-intercept is at the point 2, 0. Now I could have gotten that. I could have gotten that x-intercept algebraically by putting a 0 in for y. So that would be like 0 equals 2 to the power of x minus 2 minus 1. And then solve it. I'd add 1. And then I'd rewrite it as a log. The log base 2 of 1 equals x minus 2. The log base 2 of 1 is 0. If I add 2, I get x equals 2. There is my x-intercept at 2, 0. So I could do it algebraically like this, or I could think through it graphically. Now, my y-intercept is right here. It's between 0 and negative 1. This one I'm going to do algebraically. So I got to go 2 to the power of 0 minus 2 minus 1. Because remember, my y-intercept is going to have a 0 for the y value because it's hitting the y-axis. It means a 0 for the y value up there. Okay? 2 to the 0 minus 2 minus 1. I'm just going to type I'm too drowsy to figure that out right now. 0 minus 2 minus 1. And I get negative 3/4. Okay, so I started out graphing it. By the way, the domain, this is exponential. Every exponential has the same name. Domain, negative infinity to infinity. There's the domain of that function. Okay? So the domain is negative infinity to infinity. The x-intercept, so let's do this. The domain is negative infinity to infinity. The x-intercept is 2, 0. The y-intercept is 0, negative 3/4. The asymptote, well, it had an asymptote right there. Well, that's at negative 1. So more specifically, it's at x equals negative 1. Not x, y, because it's horizontal. A vertical asymptote will be x equals. And then graph the function using transformations. That's what I did right there. Okay. So put that together and you've got 14. No, that's 13. Negative infinity to infinity. 2, 0. 0, negative 3/4. And then y equals negative 1. Okay. Now. Okay. Let's do the same kind of thing, but with the next equation. 14 asks for logarithms, and I haven't done any of this, so this is all wrong. Okay. Log base 4 of x plus 2 minus 1. X plus 2 minus 1. Okay. State the domain in interval notation. Okay. A few ways to think about it. I can think about this with transformations if you're well aware of what the logarithmic graph looks like. Okay. I want to take a little bit different approach from what I did in the last problem here. Okay. Although I could graph log base 4 of x plus 2. It's going to go through that point, 1, 0, and it's going to go through 2, 3, 4, 1. And it has a vertical asymptote right at y equals 0. And I could look at that and I could say, oh, it's going down 1, right 2, and I could do that. Okay? And I guess I'm going to have to do that eventually, aren't I? Down 1 and not right, but left 2. Okay? Even if you're not quite sure your parent function, you do that. Now, if I take that down 1, left 2. Down 1, left 2. This has a vertical asymptote there. This is going to have a vertical asymptote right there. And then I take every one of these points. Down 1, left 1, 2 right here. And then I take this point here. 1, 2, 3, 4. And I go down 1 and left 1, 2. And there's my graph. Now, worst case, remember, I can actually type that into a calculator, do a T-chart. So don't be afraid of using just a T-chart there. Now, let's look at this. And I said I was going to do it different. I was going to do a T-chart to graph this, but since I'm going to have to do transformations anyway, I need to start with the basic graph without this transformations, the down 1, left 2. Okay. Now, I know that every logarithmic graph, just a basic log base 4 or log base 4 something, it's going to go through the point 1, 0. It's also going to go through the point, whatever its base is, 1. So 4, 1. Okay. Now, the x-intercept. X-intercept, if I have the graph, I could look, oh, there the x-intercept, it's at 2, 0. Okay, if I don't have the graph, I can always go 0 equals the log base 4 of x plus 2 minus 1 and solve it. So I'd add 1 to each side, and I'd go 4 to the power of 1. That's 4 equals x plus 2, and I know I skipped a couple of steps. I could subtract 2 and I get x equals 2. Okay, the y-intercept. The y-intercept, I know it's going to be between 0 and -1. I don't know what it's going to be, though. So I'm going to go y equals the log base 4 of 0 plus 2 minus 1. Because I know the y-intercept is going to be something 0. Or 0 something, excuse me. So I'm just putting the 0 in for the x value. Okay? And if I put that in my calculator, log base 4 of 0 plus 2 minus 1, I get -1/2. So y equals -1/2. So it's going to have a y-intercept at 0, -1/2. Cool. Okay. So, oh, and the domain. The domain of this, check it out, goes from 2 to infinity. The reason for that is the interior of that logarithm, the x plus 2, has to be greater than or equal to 0, so x has to be greater than or equal to -2. So there's my domain, or my domain is just from -2 all the way to infinity. The x-intercept was 2, 0. The y-intercept was 0, -1/2. Asymptote was at x equals -2. X equals -2. And then I graphed the function. Okay. Last problem on here, right? And it says to solve this thing. I think I can do it over here. Okay, I've got a log plus a log. Well, I need to combine these. I'm going to combine these into one log by just going to the log base 8 of this times this. Well, x times x is x squared. -2 times x is -2x. And that equals 1. Okay, rewrite. So 8, that cancels, and I get x squared minus 2x equals 8 to the first, which is 8. I'm going to subtract the 8. X squared minus 2x minus 8 equals 0. That I can factor. X minus 4, x plus 2 equals 0. So x is equal to 4 and a -2. And if I think about putting 4 in here, 4 minus 2, that's 2. That's okay. 4 is okay. But if I put a -2 in here or here, that's gone. And so x equals 4 is my only solution because -2 is extraneous. Guys, that's it. I apologize for the yawning. Okay. Talk to you again. Bye-bye.